You like that story? I don't. I'm embarrassed. All right, here we go. Let's do this one. Number 3. I'm not going to do them all. Let's do number 3. Now, how about think of this as 1 square root? So if I think about that as 1 square root, that would be the square root of, can I simplify? What's 44 over 11? 4. You guys are like, I'm afraid to tell him the wrong answer. He might do something to me. 4x square root of 4x squared. What's square root of 4x, guys? 2x. Done. Done. So like, and then a lot of these you're not going to have a calculator for. So like, look at number 4. This is totally not a calculator problem. So the majority of your test is non-calculator, then you got some at the end that are calculator. So first of all, anything raised to a negative power, let's immediately think of it as 1 over 16 raised to the positive 3/4 power. Would you agree? And then here we go. What? Remember, roots grow in the bottom. What's the 4th root of 16?
4.
No, the square root of 16 is 4. What's the 4th root of 16? 2. What's 2 cubed?
8.
So our answer is what? 1/8. It needs to be that easy, guys. Okay, it needs to be that easy. Let's do number 6. First of all, I got everything raised to 3/4. How about we simplify inside first? So 4 over 64 would be 1/16, right? And then how about we move these two up and make it 1x to the 5th, and now everything is raised to the 3/4. How'd I do? I did good? Good. Then look at this. This is just like this one over here. Let's do the 16 first. What's the 4th root of 16? 2. And what's 2 cubed? 8. So I have 8 in the denominator. And I have x to the 5th raised to the 3/4, which becomes x raised to the 15/4. Done. What do you guys think? Wait, let me see here. Let's do number 7. Let's do number 7. Here's my recommendation. Simplify here first. Doesn't that make it a lot easier now? So that would give me 4 square root of what? Ooh, I love it. 20x to the 5th. We already went ahead and moved. We already went ahead and moved these two up here. And now we can break down the square root of 20. That's 4 times 5. What's square root of 4? 2 times this 4. 8. And what's the square root of x to the 5th? X squared, square root of what left over? 5x all over 3. Cool? Okay. I'm going to scroll down a little bit again. All right. Let's do number 10. Let's do number 10. So in number 10, I have the 4th root of 9x cubed. Now that doesn't simplify, but I can't have a radical in the denominator. So I need to rationalize the denominator by multiplying by the 4th root of what? Go ahead, Taylor. 9x. She's right, because this is why. Isn't 9 2 3s? With 2 more 3s would give me the 4th root of 3 to the 4th. And then here we go, x cubed, and x would be 4x's. So you got to multiply both the numerator and denominator by the 4th root of 9x. So obviously our numerator becomes 5 4th root of 9x all over what, guys? 9x. Oh, I'm sorry, that's wrong. All over what? 3x. Thank you, because it was the 4th root of 3 to the 4th. So number 14, we're going to FOIL that binomial. And cube root of 4 times the cube root of 2 is a cube root of 8, which is what, guys? 2. Your outer would be just simply negative cube root 4. Your inner would be positive 2 times the 1 in front would be 2 cube root 2. And your last term would be 2 times negative 1, which is negative 2. And I get, yeah, look, these 2's go away, don't they? So I'm left with just negative cube root 4 plus 2 cube root 2. Neither one of those cube roots simplify, and they're definitely not like terms, so that's what I end up with. Okay. All right. Let's keep scrolling down here. Maybe. Let's do 20. Let's do 20. So number 20, what's 2 to the 6? Let's see, 2 to the, let's see, 8, 16, 32, is it 64? Yeah, so 64. I to the 6th. You think I'm okay with I to the 6th? So I to the 6th has an I to the 4th, which is 1, and I squared. Agree? What's I squared, guys? So what's our final answer? Nice, negative 64. Okay. I'm trying to think of what I've already discussed today too, so I'm not being repetitive. And I want you to have the opportunity to work some of these out. 22, what would you multiply by? We're not going to do it, but what would you multiply by? The conjugate, which would be in both top and bottom, okay? Let's do a solve one. Let's do 24. Let's do 24. I know we already did one on the board, but let's do one more. So let's get rid of this radical. So let's square both sides. And now I have 2x minus 1 equals, and then this binomial squared is x squared minus, what would that be, 16x plus 64, yes? Okay, and then we're going to subtract the 2x over, add the 1, and I'm going to have 0 equals x squared minus 18x plus 65. Help me factor that, please. Manachi, you're like a factoring stud. On Tuesday, you're the one that threw out the factoring immediately at me on 1. I remember that stuff. Okay? So, x, what is it? Come on, Manachi, I just called you a factoring stud, so what do I put, though? What signs?
Minus 5 and minus 6.
Okay, thank you. And then, therefore, we get x equals 5 and x equals 13. And we're just going to circle them blindly and move on, right? No, we're going to check them back in the original. Let's check 5. Here we go. You can hire me for the time being. Here we go. 2 times 5 is 10 minus 1 is 9. Square root of 9 is 3. 5 minus 3 is negative 3. Uh-oh. 5 doesn't work. It's a what solution and extraneous. Let's plug in 13. 2 times 13, 26 minus 1 is 25. Square root of 25 is 5. 13 minus 8 is 5. So only 13 works. Nice. Okay. Okay. And what else do we have here? Let's see. Oh, we have some graphs. You guys don't need me to go over graphing, do you? You guys got that down, right? You guys do want me to graph? I'm being sarcastic. I'm confident that you need me to go back over it one more time. I'm going to do both of them. The one on the left is a square root. The one on the right is a cube root. Okay, let's do the square root. Here we go. X, Y. It's a square root. Where do we start at? 1, 2. So I'm going to write 1, 2. And then I'm going to go 1, 4, 9. So 1 plus 1, 2. 1 plus 4, 5. 1 plus 9, 10. And I'm going to have a little XY chart for you to fill in, okay? And now, what's the number in front of the square root? -3. That means our y values are going down increments of 3. So this would be what? -1, -4, -7. Mr. Dice, I got to plug in 1, okay? 10 minus 1 is 9, square root of 9 is 3. 3 times -3 is -9 plus 2, -7. Okay, now I feel good about it. Let's plot the points. So 1, 2, 2, -1, 5, -4, and 10, -7. It's doing that, isn't it? Which makes sense. It's been reflected because of the negative. And what would the domain be? What would the domain be? Genevieve, what would the domain be? Nice. Inclusively 1 to infinity. And Taylor, what would you get for the range? Be careful.
Negative infinity to the parentheses.
Inclusively 2.
Yeah, I don't know
The word inclusive? Now you do.
what.
Inclusive.
Okay.
So now we have cube root. So with a cube root, the vertex is -2, -3. But remember with the cube root, you put that in the middle. Why? Because you can have positive and negatives underneath the cube root. And what am I going to count by for cube root? 1, then 8. So what's -2 plus 1? -1. What's -2 plus 8? 6. What's -2 minus 1? -3. What's -2 minus 8? -10. Okay? What's the number in front? -1/3. That means we're going to go increments of -1/3. Y'all with me on that? So don't freak out. What's -3 minus 1/3? -3 and 1/3. What's -3 minus 2/3? -3 and 2/3. See, that wouldn't be fun to plug in. It's a lot easier to understand. And now go this way. We're going to go backwards, if you will, which plus 1/3. So this would be -2 and 2/3 and -2 and 1/3. So what I recommend is this. Watch me graph it. Start with the vertex. -2, -3. And I'm going to work, look up here, I'm going to work these points. -1, -3 1/3. So -1, -3 1/3. That's about right there. You with me? And then I'm going to work 6, I'm going to work 6, -3 and 2/3, which would be about right there. Following what I'm doing? Other way, I'm going to go -3 and -3 and -2 and 2/3 is like right there. And then -10 and -2 and 1/3 there. So it looks like this. It's just a snake that's been really compressed. Domain and range for both of these are -infinity to +infinity. Okay?